Good morning, everybody. My name is Gulshan Kumar, and your chemistry teacher. This is a lecture based on defects or imperfections in solids from first lesson, solid state. So, today I am going to tell you about the defects and which are the important question will come on this topic. Okay, so today our topic is defects. Okay, so imperfections or defects in solids. So what do you mean by defects, irregularities, imperfections in solids? So any departure from perfectly ordered arrangement of constituents particle in crystal is called imperfections or defects. Departure means any irregularity in the arrangement of constituent particle, and constituent particle may be atoms, ions, molecules. So any irregularity along the line, that is line defect, and as a point, that we say point defects. So imperfections or defects in the solid arise due to two reasons. First is point, and second due to irregularity in the lines. So broadly we are dividing these defects into two categories. First is point defects and second is line defect. But in your syllabus we will study about only point defects. Okay, so what do you mean by point defects? When the deviations or irregularities exist from the ideal arrangement around a point or an atom in a crystalline substance is called point defect. And in other hand, and when the deviation from the ideal arrangement, that means systematic arrangement, exists in the entire row of the lattice points, the defect is called line defect. Deviation means irregularity in the ideal arrangement, systematic order becomes unsystematic, so that we say the defect arising in the rows or deviation arising in the rows, systematic arrangement, that we say or regarded as line defect. So we will study about only the point defects, not the line defects. Okay, so again the point defects of three types. One is the stoichiometric defects, non-stoichiometric defects, and impurity defects. Stoichiometric related to ratio, and non-stoichiometric, that means ratio is not equal. So mainly these are three types. Okay, first is stoichiometric defects, non-stoichiometric defects, and impurity defects. So I tell you about something like a graph. So keep in mind, first is about defects, second is point defect, line defect, and we will study about only point defects. Again these are characterized into three categories. First is stoichiometric, non-stoichiometric, and impurities defects. So again we will classify stoichiometric defects, vacancy defect, interstitial defects, Skutky, and Frenkel. Similarly, in non-stoichiometric defects, we take two: metal excess and metal deficiency. So as you know, metal excess means cation excess, and metal deficiency means anion becomes in excess. So metal excess can be of two type due to by anion vacancy. If the anion is missing from the crystal lattice, then obviously the cations will be more, that is excess. By the presence of extra cations, if any extra cation is coming in the crystal lattice, so obviously the metal ions or metal will be in excess. Metal deficiency. Okay, so these are the two important, because two or three questions are most important questions are coming from this. And third, impurity defects. Now we study briefly what do you mean by the stoichiometric defects, non-stoichiometric defects, and impurity defects. So first of all, I am taking a Stoichiometric defects, that we also say intrinsic and thermodynamic defects. So what do you mean by stoichiometry? A ratio of cations and anions, so related to stoichiometry, of the solid is not disturbed, that we say stoichiometry. And if any disturbance or irregularity coming in the arrangement, that we say stoichiometric defects. So first, in this case, vacancy defect, when in a crystalline substance some of the lattice sites are vacant, the crystal is said to have a vacancy defect and arising the vacancy defect due to some vacancy created in the crystal lattice. Also called thermodynamic because such type of defect is generally arises due to the absorption of heat from the surrounding. So in this case, generally the density will decrease. Why the density is decreasing? Because density decreasing due to the vacancy creating by the missing of cations. Okay, or some vacancies is due to the missing of particles. So particle missing means density will be decreased. Second is interstitial defects, when some extra constituent particles, maybe ions, cations, atoms, molecules, are present in the interstitial sites. So what do you mean by interstitial site? These are the interstitial sites in between the constituent particles. Okay, so when any constituent is present in the interstitial sites, extra constituents, okay, the crystal is said to have a interstitial defect, and in this case obviously the density will increase. Above two defects are shown by non-ionic solids. This is also important point. So these two defects means vacancy creating and interstitial occupying. That defects is only in case of non-ionic solid. That means in ionic solid these two defects are not arising. So first is vacant lattice sites. So these are the vacant lattice sites. If they are missing, the mass is also missing, and mass per unit volume is equal to the density. So density is directly to the mass. C is also decreasing. This is known as vacancy defect. And if any extra constituent is coming in between the interstitial sites, okay, that also creates the irregularity and defects. So that we say interstitial defect. After this, these are the most important. First is Schottky defect. So what do you mean by Schottky defect? If an ionic crystal of the type A plus B negative, equal number of cations and anions are missing from their lattice sites, so that the electrical neutrality is maintained, is called Schottky defect. So first case, Schottky. So what do you mean by Schottky? Equal cation and equal number of anions when missing from the crystal lattice. Okay, so ratio will be same. So this is under the stoichiometric defect, means ratio still remain same, and to maintain the electrical neutrality the cations and anions should be same. So that also maintain the electrical neutrality even after missing the equal number of cation and anion. That we say Schottky defect. So don't create any confusion between Schottky defect and vacancy defect. Okay, so vacancy is also somewhere related to Schottky, but in this case specially the ionic crystal is mentioned when equal number of cations and equal number of anions are missing, the ratio remain also same. Okay, and to maintain the electrical neutrality only equal number of cations and anions are missing. So what can be in this case after creating the defects? First is conditions. Conditions for ionic compounds to show Schottky defect. First is should have high coordination number. Coordination number means the neighboring constituent particle should be in high coordination number. And second is small difference in the size of the cation and anions. In this where the cations and anions has approximate size are equal or minimum, that creates only the Schottky defects. And third, due to this defect, density is decreasing. So many small questions, 1 marks, 2 marks are coming like this. The density will decrease, what will be the type of defect? Okay, density will increase. So increasing or decreasing density, that all questions we will summarize in the case of differences between the Schottky and Frenkel defect. Next is Frenkel defect. If an ion is missing from its lattice site, and especially which ion, and it occupies the interstitial site, electrical neutrality as well as the stoichiometry of the compound are maintained, is called Frenkel defect. Types of compound exhibiting Frenkel defects. What are the condition? Condition is first should have low coordination number and large difference in the sizes of anion and cations. Okay, so these are the two diagrams that will help you to understand. First is Schottky defect, where the size of the cation is approximate equal, no large difference between the size. In this case, there is a large difference of cation and anions. So who can occupy the interstitial site which has small size? So which has a small size? Cation. And in this case, cation has a large difference with the anion size. So cation will be very less in size as compared to anion that occupy the interstitial site, not the anion. Keep in mind, not the anion will occupy the interstitial sites, only the cation will occupies the interstitial site. In this also, the density will remain same or not. Look at, because this cation is coming here. Okay, so let me see, the density remains same. In this case they are missing out, so density will decrease, but in this case no any extra cation is coming from outside, only from the crystal that will displace its position and go in the interstitial sites, that create the vacancy as well as interstitial defect. Okay, so that show the uh, same density even after creating the defects due to this reason. So these are the important Schottky and Frenkel defect. In next we see the difference between Schottky and Frenkel defects. What are the main difference? This is the most important question in the solid state. Okay, small 1 marks, 2 marks and maybe of 3 marks question come from this article. So first difference is the definition, as you know, the Schottky defect and Frenkel defect. First difference is it is due to equal number of cations and anions missing from its lattice sites, and in this case it is due to the missing of ions, only cations, from the lattice sites, and these occupy the interstitial sites. In second case, it lowers the density of the crystal. After creating the defects, density of a crystal will decrease, but in this case the density of the crystal remain unaffected or remain same. In third point, the type of defect is found in highly ionic compound with high coordination number and having cations and anions of similar sizes, but in this opposite. This type of defect is found in crystal with low coordination number and in which the difference in the size of cations and anions is very large. So these are the example after the differences: NaCl, cesium chloride, potassium chloride, potassium bromide. Okay, so I underline this point and this will in both sides. So this is also important question. We show the both Schottky as well as Frenkel defect. So this is one of the example of silver bromide. Show both side. The defect can be show Schottky as well as Frenkel defect. Okay, so keep in mind silver bromide. Okay, so in these cations and anions have a large difference of cation and anions, and in this case the size difference is not so with the difference of the size of the cation and anions are not so large. But especially silver bromide lies in between these two regions and have a capacity to show both kind of Schottky as well as Frenkel defect. So this is also important. Listen, which alkali metal halides do not show Frenkel defects, and because the cations being of large size and does not fit in the interstitial size space. Alkali metal halides, especially alkali metal halides that are not coming in this case, okay, like sodium chloride, potassium chloride, cesium chloride. First alkali, lithium chloride, sodium chloride, okay. So these alkali metal halides are not coming to this side. So that specially show the Schottky defect, not the Frenkel defect. So alkali metal halides do not show Frenkel defect because the cation being of large size. So in the periodic table left side, the element in the periods always have a large size. So alkali metal has large size in comparison to halogen elements. So alkali metal halides do not show any Frenkel defect because the cation being of large size does not fit in the interstitial side. This is also important conceptual question. So in this lecture I am going to I told you only about the defects and up to the Schottky and Frenkel defect. In next lecture we will study about the non-stoichiometric defects, and these are the important article, and after this we will study about the impurity defect. Okay, so today I am giving some of the assignments based on these. So this is the assignment and some questions, small important, and these are the two most important questions, 7th, question number 8th, and question number 9th. But all these are concept wise are important. So I am sending this assignment, you have a need to do it. I am going to deliver a second lecture on defects and giving a second assignment on defects tomorrow. Okay, so I hope you will try to do this, and I am going to show you the books also. I have two books. One is the modern chemistry, so here about the solids defects also given very good in manners. So these are the difference between the Schottky and Frenkel defect. Okay, so up to this we will study in this book. So in next lecture I will tell you about the books, and we have a second book is also there. Second is your Newton that I changed by last session. So these are the defects, point defects, okay, is given very good, and I am sending you the notes, okay, notes related to defects. Okay, you can study the notes also and try to complete this assignment. Okay, so have a good day, stay at home, stay safe. Thanks very much.